In this next video, we're going to do a quick review on how to work with fractions when we perform our mathematical operations. So let's go ahead and let's take a look at a couple of examples. For the first one, we are going to do 4 over 6 plus 3 over 6. Now when you have two fractions with the same denominator, that would be the bottom part right here. This is what we would call the denominator. What we can do is we can go ahead and simply add the numerator together. So this is going to be 7 over, and we have to keep the same denominator when they're equal, 7 over 6. If you also want to think of this a different way, you can write it out simply as 4 plus 3 all over 6, because we're keeping the same denominator when they are both equal. So furthermore, if we did not have the same denominator, say we had 3 over 5 plus maybe 4 over 6, this can be quite an issue because now we can't simply keep the same numerator. So what you have to do is you have to give them both a common denominator, just like we have over here. So let's branch this off for one moment. So what we're going to do in here is we're going to find a common, greatest common factor that these two have. So the easiest way that I like to do is I like to simply multiply 5 times 6 and 6 times 5, because we know those two answers are equal. We're going to go ahead and we're going to multiply 5 times 6. We're going to rewrite this here. 5 times 6 is 30, and 6 times 5 would also be 30. Now that we have the same denominator, though, we have to go ahead and change our numerator, because once we change the denominator, we also have to change the numerator. So for this fraction, what I did was I multiplied the denominator by 6 to go ahead and get 30. So we also have to do the same for the numerator. So 3 times 6, just keep in mind we also have to multiply this 3 times 6. I'll actually write this out down here too so you can see what I did. 5 times 6. So 3 times 6 would be 18. And then we have to do the same right here. In order to get 6 to 30, we had to multiply by 5. So this was really 6 times 5. So that way we also have to do 4 times 5 here. And then 4 times 5 would be 20. And now that we have the same denominator, we can go ahead and we can add these two together. And so we are going to get 38 on the top. And for now, we're going to leave this as not an improper fraction, but the numerator is greater than the denominator. So we're just going to leave it this way just for now, and then we'll take a look at how to reduce in just a minute. But let's go ahead and let's take a look at an example of subtraction. So the same exact process is going to take place. Maybe for this example, we will have 7 over 6 minus 3 over 6. Well, we do have the same denominator, so right away we can go ahead and, if you wanted to rewrite this way, you can. It's easier just to do the simple subtraction in your head. This is going to be 4 over 6. And if you wanted to reduce it just like you could up here, this would come out to 2 over 3, but either way is fine just for now. But let's take a look at an example where we don't have the same denominator. Maybe we'll do 4 over 6, and maybe we'll do 3 over 5. So just like we did over here, we have to get the same denominator on the very bottom. So of course it's going to be 30, because we have to multiply 6 times 5, and then we also have to multiply 5 times 6. So we have the two denominators as 30. And so what we did to the bottom, we have to do to the top. So we multiplied the 6 here by 5, so we also have to multiply the 4 by 5. So that's going to be 20. And of course we have to do the same over here. We multiplied this by 5, so we have to multiply the 3 by 6, so that's going to be 18. And now we have 20 minus 18 over 30, just like this. And this is going to come out to be 2 over 30, or when we reduce, that's going to be 1 over 15. Now I want to take a look at one more example that could be similar to these. Ooh, give myself a little bit more room here. Suppose we are given the fraction maybe 3 and then 2 over 3 minus 2 and 1 over 4. Now right away we actually cannot go ahead and do any operations here. For one, we don't have the same denominator, but we also don't even have the same number in the front right here. So what this really means is we have to go ahead and we have to change these into a regular fraction. And if you remember from when we first learned how to do fractions, I believe in pre-algebra, the way that you would go ahead and change this into a fraction just like this is you leave the denominator 3. Let's go ahead and write this like this. But then you multiply the denominator and the number right here. So I'm just going to rewrite this now for 9. And then you take whatever that number is and add it to the very top. So of course the top was 2. So what this fraction is going to be is 9 plus 2. Well, that's going to be 11. So it's going to be 11 over 3 because we have to multiply this, and then whatever that result is, we add it to the top. So let's do the same right here. We're going to leave the denominator as 4, of course, but then 4 times 2, we know that's 8, and then 8 plus 1, we know that's going to come out to 9. So that is our numerator. And yet, of course, we still don't have the same denominator. So I'm going to give us a little room over here, and we can go ahead and finish this problem. So we have to get the same denominator, of course. So let's go ahead and do some more work over here. Let's rewrite this and make it look a little bit neater, I should say. So we have to, first of all, multiply the two denominators together to get the same common denominator. So this is going to be 3 times 4, and this will come out to be 4 times 3, multiplying these two together. So let's go ahead and let's set our denominator. 4 times 3, these are 12. So we're going to have 12, and then subtract whatever numerators we get. And these, let's go ahead and do the rest of our multiplication. This is going to be 4 times 11 because we have to multiply just like this, like we did here, which is going to come out to 44, of course. And then we have to do 3 times 9, just like we did down here. 3 times 9, of course, just like this. And then we can subtract whatever these are up here. And let's go ahead and write 27. That is going to come out to be 17 over 12. Now, just like this example right up here, when we did not reduce or change it back to a fraction like this, what we can actually go ahead and do is, think of it this way. If we divided 17 by 12, let's go ahead and do this right here. We know that 12 goes into 17 one time, so we would bring down the 12 and subtract, and we'd get a remainder of 5. Well, that's exactly what we're looking for. We have 12 goes into 17 one time, just like this. We can write it like this, and then we would have the remainder 5 over 12. So that's exactly how you would get it back into that form, just like that. And the last example, or we're actually going to go over 2 more examples, but now what we're going to do is we're going to go over multiplication and how you would go about multiplying. So say we had 3 over 4, and we wanted to multiply that fraction by 5 over 6. Now, luckily for multiplication, we don't have to worry about keeping the same denominator. We can go ahead and get right into our multiplication. So what this is actually going to be, is going to be the numerator, the very top, times each other. So this is going to come out to be 3 times 5, whatever that result is going to be on top of the same result down here. 4 times 6. You just have to simply multiply across, just like this. And of course, multiplication can still be written with the classic X right here, but in algebra, you're going to start seeing the dot used more often. So this is going to come out to 15 over 24, because 3 times 5 is 15, and 4 times 6 is 24. And then we can actually go ahead and reduce this to 5 over 8, because we divided by 3. 15 divided by 3 is 5, and 24 divided by 3 is 8. So let's go ahead and let's take a look at a division problem for our very last one, because division can be a little bit confusing sometimes. let's go ahead and let's actually do the same division as we did up here for this problem. Let's do 3 over 4, and we're going to divide that by 5 over 6. Now, the very first thing that we have to do is we have to take the reciprocal of 6 over 5. And what that means is we're just going to simply be flipping 5 over 6 so that the 6 is on top of the 5. So this problem is going to be rewritten just like this over here as 3 over 4. And then you have to rewrite this as 6 over 5. Whenever you do division, you have to do the reciprocal of the second number. It's very important that you do the second number. Then after we take the reciprocal, this will become a multiplication problem. Division will become multiplication. So this sign right here is going to change to multiplication. And so now all we have to do is just simply multiply right across. 3 times 6 is 18, and 4 times 5 is 20. So we have 18 over 20. Then we can go ahead and we can reduce this. If we go ahead and divide by 2, because 2 is a common factor in both these numbers, we would end up getting 9 over 20, or 9, excuse me, 9, let's go ahead and fix this, 9 over 10. 20 divided by 2 is 10, and that would be our final answer, 9 over